Hello guys, and welcome back to my YouTube channel. This video is part of our tutorial series on standard template library in C++. So in previous video we take a overlook on the STL and we saw how many type of containers and different concepts of STL. Now in this video we will start the concept of algorithms in STL, and our first topic will be sorting. So let's get into it. Sorting is one of the most basic functions applied to a data. It means arranging data in a particular fashion, either in ascending order or descending order, which can be increasing or decreasing. There is a built-in function in C++ STL by the name of sort. This function internally uses intro sort. In more detail, it is implemented using hybrid of quicksort and heap sort and insertion sort. By default it uses quicksort, but if quicksort is doing unfair partitioning and it takes more than n key power log n times, it switches to heap sort, and when the array size becomes really small, it switches to insertion sort. So basically this sort is hybrid of three sort: quicksort, heap sort and insertion sort, and it applies them according to the complexity of data. Now we will take a look at prototype of this sort. First of all, we have our keyword sort. Then it accepts two arguments. First one is start address, from where which we want to start the sorting, and second one is end address. The address of the first element of the array is start address, and the address of the next contiguous location of the last element of the array is the end address. So actually sort sorts in the range of start address and the end address. Now we'll take a coding example of that. So let's me clear this code from our previous videos. Now for using the sort algorithm, we have to include these two. Algorithm. Now first I will type the code for displaying our sorted array. I will name it show. It will accept an integer type array and then an integer type of let's say size. Name it as array size. Now inside of this we will run a loop. Sorry, there is a spelling mistake above. It is array size. Then we have our increment. Now we will move to our main driver code. Inside of it I will first initialize an array, and it will contain of unsorted integer. integer from 1 to 10. Let's say now the size of array. Now we will first print this before passing it to our sort algorithm. Now we will call our show function and pass it to array and a size. Now we will sort the array by sending the array and size to our sort algorithm. Now we will again print this array to check if it is sorted or not. Let me just align this code. So yeah, I've proper commented this code so you can see this. Now let's run this program and see what we will get. So you can see at first we have our unsorted array, and at second number we have our sorted array. So it has done the job quite well. Now let us see how we can achieve quick sort in C++. So I will delete all of this. And we also do not need this, so it's okay. Now first of all we will define our function. For partition, it will accept an array of integer type and an int start value or index, and then an integer type of end index. Then inside of this function we have our pivot, which will be equal to the start of our array. Next we will have our count will be initially equal to 0. Then we have our for loop. Now for the body of this for loop we will have our condition if the ith index of array is less than or equal to pivot, then we will increase the count by 1. Next we will write our code for giving the pivot element its exact location. So I will make an integer of pivot index and will initialize it to start index plus count. Then next we will call our swap function and will pass our first argument which be the pivot index array. Then our second argument of start. Then we will type our logic for sorting left and right parts of the pivot element. For that I will make an element of integer type I and will initialize it to the start value, then j, and initialize it to the end value. Then we will have our while loop. While I is less than pivot index and j is greater than the pivot index, if this condition is true, then we will have an other while loop. Basically it's a nested while loop inside our previous while loop body. So let's write the logic for that too. While array ith index of array is less than or equal to pivot, then we would like to increment the I by 1. Then we have our second while loop, and if the jth index of array is greater than pivot, then we would like to decrement j by 1. Then we will have our if statement. If I is less than, let me just make this bigger so you can see it easily. Yeah, so if I is less than pivot index and j is greater than pivot index, then we would like to call our swap function again. Then we will simply return our pivot index. Now we will write our function for quicksort. It will accept 3 arguments. First one will be the array, then we will have our start,